For the introduction, efficient soil qualities are now a major concern in engineering projects. Soil stabilization entails the application of a binder to the soil in order to improve the soil's engineering performance. This project will look at the effect of chemical stabilization using lime on soil parameters. According to studies, being the additive improve the workability and mechanical behavior of the soil following stabilization. The aim for this project is quicklime is frequently used to dry wet soils at construction site and elsewhere, reducing downtime and providing an improved working surface. Lime can substantially increase the stability, impermeability, and load-bearing capacity of the subgrade. Application of lime to subgrades can provide significantly improved engineering properties. Both quicklime and hydrate lime may be used for this purpose. There are three objectives for this project. First, lime stabilized layers such a contribution to pavement design can lead to more affordable design options. The second one is lime stabilization improve performance while lowering maintenance expenses. For the last one is lime is excellent choice for short term and long term modification of soil properties.
Okay, next, for the part literature review, first, definition. Lime soil stabilization is the process of adding lime to the soil to improve its property like density, bearing capacity. Next, stabilization also the process of improving the property of soil through a multitude of applications that may involve compaction, mixing with chemical additive or other non-destructive methods to have better strength and durability beside other improvements. Various factors affecting lime soil stabilization are soil type, limb type, lime content use, compaction, current period, and additive. Okay, for the second type of lime stabilization, they have two, which is number one is straighting granular or aggregate bearing material for the basic final course on which the course where or seal face will be placed. And next, treating the soil material to serve as a sub-base.
Assalamualaikum. My name is Haikal and I'll be explaining about methodology. The exchange of ions between lime and soil upon addition is the underlying concept in the stabilization of lime soil. When lime is applied to clay soil, cation exchange occurs, increasing the plastic limit and decreasing the plasticity index, which ultimately promotes soil stability. Lime serves as a binding agent for clay gravel if the clay also contains gravel. Pavement-based courses and sub-bases can be built using limestone stabilized mixes for warm places with high temperatures. Lime-treated soil is better suited. It is not ideal for colder regions. There are six methods of mixing lime. First is clarification and initial pulverization. After the soil has been leveled and graded, the subgrade can be scarified to the desired depth and width before being partially pulverized. Non-soil materials greater than 3 inches such as stumps, roots, turf, and aggregates should be removed. Simplification is used because a pulverized or scarified subgrade provides increased soil surface contact area for the lime when it is applied. Second is lime spreading. In most cases, the soil is scarified and the slurry is applied by a distribution truck. Because slurry lime is significantly less concentrated than dry lime, it sometimes takes 2 or more passes to get the desired amount of lime solids. The slurry is blended into the soil quickly after its spreading, fast to prevent runoff and thus non-uniform lime distribution. Third is preliminary mixing and watering. To disperse the lime throughout the soil and to pulverize the soil before adding water to start the chemical reaction for stabilization, preliminary mixing is required. Water should be introduced throughout or immediately after this process to achieve thorough hydration and a quality stabilization process. Next is final mixing and pulverization. The thorough dispersion of lime throughout the soil as well as suitable fine pulverization of the clay fraction are required for complete stability. And for compaction, using a ship's foot type roller or a vibratory pad foot roller, initial compaction is normally done as quickly as feasible after mixing. Final compaction can be done with a smooth drum roller after the portion has been formed. The equipment used should be suitable for the depth of the segment being built. Lastly is final curing. The compacted subgrade or subbase should be allowed to harden until laden dump trucks can operate without rutting the surface before applying the next layer of subbase or base course. The surface of the time-treated soil should be kept moist throughout this time to aid in strength increase. This is referred to as curing, and it can be accomplished in two ways. First, moist curing, which entails light sprinkling and rolling as needed to keep the surface moist. And second, membrane curing, which entails sealing the compacted layer with a bituminous prime coat emulsion, either in one or many layers.
Hello everyone, my name is Champo Chen and my mention number is AA200600. Today, I am going to present the Geotechnical Engineering Group project entitled Review of Limestone Stabilization. First and foremost, I will talk about result and discussion. Lime is utilized as an effective way to modify soils. It improves both workability and load-bearing characteristics while increasing stability and impermeability. Quicklime and lime kiln dust can also be used to dry wet soils at construction sites, reducing downtime and providing an improved working surface. The application of lime can significantly improve the engineering properties of soil. Soil stabilization occurs when the proper amount of lime is added to a reactive soil. For soil stabilization, there is a significant increase in strength, which is developed over the longer term through an ongoing pozzolanic reaction. This reaction results from the formulation of calcium silicate hydrates and calcium aluminates, as the calcium from the lime reacts with the aluminates and silicates solubilized from the clay mineral surface. The results of soil stabilization can include very substantial increases in resilient modulus values, significant improvement in shear strength, continuous shear gains over time, and long-term durability over decades of service. Furthermore, the first line stabilization worked in Malaysia to form a 6-inch lime stabilized base as a main structural element of a pavement was in the construction of Kuala Terengganu airfield. Other than that, as a global leader in lime and limestone solutions, Grandma involved in the completion of one of the largest lime transfer terminals in North America, specifically to serve the soil stabilization market in Central California. That's all from me. Thank you.
Okay, for the conclusion, for highly active soil that frequently experience shrinkage and expansion, lime is an excellent soil stabilizing material. Lime has an immediate effect and enhance a number of soil properties, including carrying capacity, resistance to shrinkage in wet conditions, reduction in plasticity index, increase in CBR value, and subsequently increase in compression resistance over time. The reaction happens very quickly and the soil stabilizes within a few hours. The formation graph provide a clear understanding of how the properties of soil have improved as a result of lime addition.